Hi students, this set of notes is over the second kind of special right triangle, and that's the kind that has angle measures 30 degrees, 60 degrees, and 90 degrees. In the 30 degree, 60 degree, 90 degree triangle, there also is a ratio of the side lengths. That's always going to be the same anytime you have that type of triangle, much like it was with the 45, 45, 90. So in this first part, before we get into the examples, we're going to go ahead and justify, prove, show where the ratio for the 30, 60, 90 degree triangles come from. So first we're going to take a look at this triangle that we've got here, and this is because all the sides are the same, this is an equilateral triangle. So we know that all the angle measures are 60 degrees. If I was to sketch in the height of this triangle, which is also known as the median or the altitude in an equilateral triangle, that altitude or median is going to split that 60 degree angle up at the top into two 30 degree angles. It's going to bisect that angle. And then we know that the two angles here and here are both 60 because we have an equilateral triangle. The altitude also makes a right angle with the base. So what we're looking at here, if I look at half of this triangle, I have a 30, 60, 90 degree triangle. What we're going to do now is try to figure out, well, what's the ratio of the sides? Currently, I don't know the length of any of its sides. So what I'm going to do, and I've already thought this through, is I'm going to call this bottom length right here x. Now this length is half of the total length of the equilateral triangle's base. And I know that because I know that medians and altitudes in equilateral triangles don't just bisect the angles, but they also bisect the sides. So that x is half of that side, which means if I double it, I get 2x, which is going to be the length of this side. Okay, so right here you can see one relationship. The hypotenuse of a 30, 60 degree, 90 triangle is 2 times the length of the side that is across from the 30 degree angle. Okay. What we're going to do is we're going to use these two side lengths with Pythagorean theorem to find the length of the third side, so you can see the ratio that these sides make with each other. So we're going to go ahead and write down our Pythagorean theorem, a squared plus b squared equals c squared. The a and the b are the two legs. One of our legs is x. The other, let's just call it y for now. Okay, so I'm going to replace these x and y for my a and b. And then my c we're calling 2x. So I'm going to have to square that whole 2x. What we want to do, we want to solve for y so we can see what its length is in terms of x, so we can see the ratio of the three sides. So I'm going to try to get y by itself. The first thing I need to do is square that 2x on the right side. And what we're going to do is we're going to square both parts. We're going to square the 2 and the x. 2 squared is 4. X squared is x squared. The next thing I'm going to do to try to get y squared by itself is move that x squared from the left to the right by subtracting it on both sides. Remember, this is like subtracting 1x squared. The x squareds on the left cancel, so I've got y squared. On the right, 4x squared minus 1x squared is 3x squared. The last thing I want to do to get y by itself, not y squared, is take the square root of y squared, which means I also have to take the square root of 3x squared. So the square root of y squared is just y, because y times y is y squared. On the right, I've got to take the square root of 3 and x squared separately. The square root of 3 is imperfect. It's going to stay under the square root symbol, but x squared, I can take the square root of that, and the square root of that is x. So the x is going to come in front. The 3 is going to stay inside. So this length right here, x squared of 2, let me see if I can do this real quick. Oops. Is going to go right here. sorry, x squared of 3 is what I meant to say, not 2. I don't know why I said that. So the ratio of the sides from shortest all the way to the longest, the shortest is the side across from the 30 is x. The side across from the 60-degree angle is x squared of 3. And the hypotenuse, the longest side across from the right angle, is 2x. All three of these expressions have an x. If I divide them all by x, I'm going to get 1. I'm going to get 1 times square root of 3, or square root of 3. And then I'm going to get 2. This is the ratio of the three sides of a 30, 60, 90 triangle from smallest to largest. So we're going to use that now to go ahead and find some missing sides of other special right triangles with those angle measures. So anytime that you're solving for a missing length in a 30, 60, 90 triangle, you got to make sure you've got that. The first thing you're going to do, just like we did with the 45, 45, 90, is we're going to write 30, 60, 90 to stay organized. Below that, we're going to write the ratio of those sides that we got from the previous example. 1, square root of 3, and 2. Now, the hardest thing is for you to make sure that you don't get this ratio mixed up with the ratio for 45, 45, 90. Remember, that one was 1, 1 square root of 2. This one is 1 square root of 3, 2. So it's a little bit different, real easy to get mixed up. Make sure you've got those written down somewhere. So this 1 square root of 3 and 2, these are going to be the numerators of three fractions that are all equivalent. To get the denominators, these are going to be the sides that are across from these angle measures up here. So let's go ahead and take a look at our triangle. Across from the 30 would be this side right here. So you actually physically have to think what side is across from a 30-degree angle, and then that's going to go in this denominator. The side across from the 60-degree angle, draw an arrow, that's going to point to the other leg. That's going to go here. It's very important not to get these two mixed up. And then the side across from the 90 is our hypotenuse. That's a little bit easier to recognize. That's always going to go in the denominator of the last fraction. Once you've got these three side lengths in the right spot, whether they're variables or numbers, then you are ready to make some proportions. Now the 30, 60, 90 triangles usually involve a little bit more work than the 45, 45, 90s, because in the 45, 45, 90s, two of the sides were the same length. So that kind of cut out some work for us. Here, in this type of triangle, all three sides have different lengths. So many times there are going to be two unknown sides. You're going to have to set up two different proportions. So it's a little bit extra. Just go ahead and pay attention. But this is really what you need to remember and use for these type of triangles. For all these examples, we're going to find the values of the missing sides for each of the 30, 60, 90 triangles. Even though we know they're all 30, 60, 90, you always want to kind of stop and make sure that you've got a 30, 60, 90. Because I see a 90-degree angle here and a 60-degree angle here, I know if I add those I get 150. If I subtract from 180, that means this other angle is 30. So if you see the right angle and either 30 or 60, you know the other angles, the other missing angle respectively is 60 and 30. So we've got a 30, 60, 90, so that's good. So the first thing we're going to do is we're going to write 30, 60, 90 to get organized, and we're going to write our ratio, which is 1, square root of 3, and 2. This is what you have to memorize. Remember, these are the numerators of the fractions we're setting up. We're going to fill in the denominators with the sides across from the 30, 60, and 90-degree angles. So the side across from the 30-degree angle, I don't know. I'm going to call it X. That's going to go here. The side across from the 60-degree angle, I also don't know, but I know that it does not equal X. It's going to have a different length. So I'm going to introduce a second variable. Let's call it Y. And then the side across from the 90-degree angle, that's this 14 here. That's the only side length that I know. Okay? So we have set up our ratios. They're all equal. Now it's our choice to set up our proportions. Remember, we just need 2 of these fractions to make a proportion. So the first thing I'm going to try to find is LM, which I'm representing with y. So I must have the ratio that has the y in it. The other ratio I want to set it equal to must have just numbers and no other variables. So that would be the 2 over the 14. Those 2 ratios I want to set equal to each other. So this is going to be my first proportion. Let's go ahead and solve it. We're going to cross multiply. Y times 2 is 2y. Oops, oh no. Excuse me. 14 times square root of 3 is 14 square root of 3. These cross products are always going to be equal. Now we just have to solve for y. We're going to do that by getting rid of the 2, which is going to be by dividing both sides by 2. 2 divided by 2 is 1. Y equals. Now the way I would divide this, because 2 is not under the radical symbol, I'm only going to divide it into that 14 that's also outside of the radical symbol. So I just have to simplify this part of the fraction, which is 7. 14 divided by 2 is 7. And then the square roots of 3. So this is the length of y, which was LM. So LM has a length of 7 square roots of 3. Now we're going to go ahead and try to find the length of MN. MN is here and is represented by x. So now I need to set up another proportion with the ratio that has the 1 over x, which is this one. I don't want to set it equal to the middle ratio because that also has a y. So I do want to set it equal to this last one, 2 over 14, because it just has numbers. I'm going to go ahead and rewrite this one since they're not right next to each other. 1 over x equals 2 over 14. Okay, we're going to go ahead and cross multiply. X times 2 is 2x. 1 times 14 is 14. Cross products are equal. To solve for x, very simply, I'm going to divide by 2. So x equals 7. So this is the length of MN. And what I want you to notice is that the side across from the 30, that's my x, right? That's 7. That is half of the hypotenuse, which is 14. So the short side will always be half of the hypotenuse. The hypotenuse will always be 2 times the short side. 14 is twice 7. The middle side, which is this guy, is always going to be a little bit different. In example 2, let's first verify the type of triangle we have. I see a 90, a 60. I know the other angle measure is 30. So let's go ahead and write down our 30, 60, 90. The ratio below that is 1, square roots of 3, and 2. And these are the numerators of our equivalent fractions. In the denominators, let's put the sides that are across from these angle measures. Across from the 30 is 2 square roots of 5. So that's going to go in this first denominator. Across from the 60 is an unknown side. Let's call it x. And then across from the 90 is an unknown hypotenuse. Let's call it y. So here are our 3 ratios. Let's go ahead and set 2 of them equal to find our first missing side, which is LM. LM is x. So I need the middle ratio, and I want to set it equal to the first ratio because it doesn't have the other variable. Whenever I have these proportions, I want to have only one type of variable in them. Let's go ahead and cross multiply. 1 times x is 1x, or x. 2 square roots of 5 times square roots of 3. For these, I want to make sure to multiply inside with inside, outside with outside. So the 2 is the only outside number. The 2 inside numbers are 5 and 3. When I multiply those, I get square root of 15. Those cross products are equal, and wouldn't you know, I already have my value of x. 2 square roots of 15 is also the length of LM. Okay, so that one's pretty easy. Now let's go ahead and find the length of y, or ln. So I'm going to use this last ratio. I want to set it equal to the other ratio that was just numbers, which is the first one. I'm going to rewrite them so that they're next to each other again. 1 over 2 square roots of 5 equals 2 over y. Let's go ahead and solve this proportion. 1 times y is 1y, or y. 2 square roots of 5 times 2. The two outside numbers are the 2, so 2 times 2 is 4. The square root of 5 stays in. This also is already solved. So y equals 4 square roots of 5. So the hypotenuse ln has a length of 4 square roots of 5. For example 3, I can see I've got a 90-degree angle, a 60-degree angle, so I know that the other angle up here is 30 degrees, so I know I have a 30, 60, 90. So I want to write 30, 60, 90. Below that I want to put 1, square root of 3, and 2. Please make sure that you're writing all this down. It's one thing to watch, but it's another thing to write it down and try to practice getting it into your brain. When you do these a lot, you'll be able to do them much faster, but you have to practice. These are the numerators of our equivalent ratios. Let's go ahead and put these side links below them. Across from the 30-degree angle is MN. I don't know its length. Let's call it X. Across from the 60-degree angle is this 8. And across from the 90-degree angle is my hypotenuse. I also don't know its length, so let's call it Y. Here are my equivalent ratios. Oh dear. Sorry about that. Let's go ahead and solve for ln, which equals y in my picture. So I'm going to use that last ratio, 2 over y, and I'm going to set it equal to this middle ratio because it does not have any other variables. Let's go ahead and solve this proportion. Square root of 3 times y is y square roots of 3. 8 times 2 is 16. These cross products are equal. To get y by itself, I'm going to divide both sides by the square root of 3. Square root of 3 over square root of 3 is 1. So y equals 16 over square roots of 3. Now fractions are okay as long as they are rationalized. I have a radical in the denominator, so I need to rationalize this denominator. We're going to multiply both the numerator and denominator by that square root of 3 in the denominator. Remember, square root of 3 over square root of 3 is 1, and I can multiply anything by 1. Let's multiply straight across. 16 times square root of 3 is 16 square roots of 3. Square root of 3 times square root of 3 in the denominator is square root of 9. And square root of 9, remember, is 3. So 16 square roots of 3 over 3. Look at your two outside numbers, 16 and 3. Those do not simplify. So this means that this is the length of y. And y was ln, so ln is 16 square roots of 3 over 3. Now let's go ahead and find the length of our remaining side, which is mn. Mn is represented with x. So we're going to use this first ratio with the second ratio. So these are the two that I'm going to use in my proportion. If you can't see that, just go ahead and rewrite it. 1 over x equals square root of 3 over 8. Let's go ahead and cross multiply. X times square root of 3 is x square roots of 3. And that equals my other cross product, 1 times 8, which is 8. So to solve this equation for x, I'm going to divide both sides by square root of 3. Square root of 3 over square root of 3 is 1. So x equals 8 over square root of 3. Once again, we've got to rationalize our denominator. So we're going to multiply the top and bottom both by square roots of 3. 8 times square roots of 3 is 8 square roots of 3. Square root of 3 times square root of 3 is square root of 9. I can write that down, or I can just think, hey, that's 3. So remember, when you multiply a square root times itself, it just equals the number under the square root symbol. And 8 over 3 as a fraction is already simplified. So that means this is the value of x, 8 square root of 3 over 3, which is also the length of mn. So a lot of times you're going to have these funky looking answers, especially after you rationalize the denominator. But make sure that you're going through this process. You will get better with these square roots, but you definitely have to practice. Here's our last example. Look at my triangle. I've got a 90 and a 60. That means this other angle is 30. So I'll write 30, 60, 90. Hopefully you're kind of getting the hang of it now. Write your ratio 1, square root of 3, and 2. Draw your fraction bars, put your equal signs, and let's go ahead and put the sides that are across from these angle measures. Across from the 30, I don't know its length, let's call it x. Across from the 60, I don't know its length, I know it's different than the x, so let's call it y. And then across from the 90, I've got this 4 square roots of 3. Okay, let's go ahead and solve for our first missing side, which is LM. LM, looks like I used a y, so I need that middle ratio, and I need to set it equal to the other ratio that has just numbers, which is going to be this last one. So here's our proportion. Let's cross multiply. Y times 2 is 2y. Square root of 3 times 4 square roots of 3. The 4 doesn't have another outside number to multiply by, so we're just going to rewrite it. The two inside numbers can get multiplied. 3 times 3 is 9. So I've got 4 square roots of 9. And I know square root of 9 is 3, but I'm just going to write it like this for now. I know these cross products are equal. So let's go ahead and simplify. I know square root of 9 was 3. So I've got 2y equals 4 times 3, which is 12. Whoops. And then to solve this equation, I would divide both sides by 2, which means that y equals 6. Y, remember, was LM, so LM has a length of 6. Pretty simple. My next one is MN, which is my x. So that's going to be this first ratio along with the just number ratio. So I'm going to rewrite those so they're next to each other. 1 over x equals 2 over 4 square roots of 3. Let's solve this proportion. 2 times x is 2x. 1 times 4 square roots of 3 is 4 square roots of 3. And I know cross products are equal. To solve for x, I'm going to divide both sides by 2. I've got x on the left. On the right, these two outside numbers I can simplify. 4 over 2 is the same as 2, and then I have the square root of 3. So x has a length of 2 square roots of 3. X represented mn, so mn has the length of 2 square roots of 3. So every problem was a little different in here. Make sure that you're doing the setup right, you're following your radical rules, and you're just solving very simple proportions. Just keep practicing. Don't get the ratio for 30, 60, 90 mixed up with 45, 45, 90. Go ahead and proceed to the practice and let me know if you have any questions. Good luck.